Hello, and welcome back to Tech Nomad. My name is Brandon Warren, and have you been keeping up with the news lately? If not, get ready because AI is taking over. The headlines. Let's find out how it thinks. But before we get started, please click the like button below. It'll really help me a lot. And as a quick side note, as you would expect, researching this topic got very complicated very quickly. So this video is intended to exemplify the basics of deep learning without getting into all the nitty-gritty and intense formulas. For a much more in-depth analysis that includes the math, I recommend checking out 3 Blue, 1 Brown's channel. They have an extremely informative video series where they dive into all of that stuff. From self-driving cars to facial recognition software, AI is becoming increasingly prevalent in our daily lives. But what is it and how does it, think? At its core, AI is about training machines to perform specific tasks by feeding them data and teaching them to learn from it. As its name suggests, AI trains machines to think on their own. Gone are the days of programmers individually inputting set responses for every possible input. There are 3 distinct levels within artificially intelligent computer science, including general artificial intelligence, a subset of AI called machine learning, and a subset of machine learning called deep learning, where we'll be spending most of our time today. At its simplest level, AI refers to the science of using rule-based systems to teach machines to follow a set of predefined rules in order to make decisions. One classic example of a rule-based system is called an expert system, which is trained through bodies of knowledge to emulate the decision-making of a human expert. This information follows an if-then structure that allows the computer to break problems down into bite-sized pieces and answer simple questions to make the correct choices. This level of AI can help doctors identify correct diagnoses from a set of symptoms or just make strategic moves in a game. Machine learning is a subset within AI that describes a system that can actually learn and improve its performance by leveraging large amounts of data that are fed into it. As showcased in R2D3's example here, sample data or training data are referenced by the machine to make predictions or decisions without those outcomes specifically being programmed into it. If any inefficiencies are detected, the system will automatically go back and adjust the leaf nodes for optimal performance. The more data the system gets to check its performance, the more accurate it will become. This approach is useful for tasks that require more complex decision-making, such that would be too difficult or unfeasible to develop conventional algorithms for. There is a wide variety of applications where machine learning is very useful, such as in medicine or filtering spam emails into a separate folder, even speech recognition software. It is truly a technological breakthrough that has improved our lives in ways that we can't even really fathom. And then there's deep learning. Deep learning is a subset of machine learning and the real heavy hitter in the media as of late. While machine learning requires human-created training models to identify distinct features, deep learning can identify an even more accurate output by analyzing all of the features of the input on its own. And no joke, it does this by simulating the structures of a human brain. This infrastructure is particularly useful for tasks that involve natural language processing, image recognition, and other complex tasks that were previously impossible for machines to perform on their own. However, this enhanced analysis and accuracy is much more computationally intensive and therefore not always necessary for every system. But okay, how does it work? Mimic the complexities of a human brain? Well, here's where it gets complicated, so sit tight. Like our brains, deep learning networks are made up of thousands of computational units called nodes. You can think of them like they're artificial neurons. The connection that these neurons have form a neural network. Each layer builds on the output of the previous layer to process large amounts of data and extract meaningful patterns, eventually producing a final output. To better conceptualize how all of this works, imagine these neural networks as office buildings that are dedicated to answer a single question that you ask it. Each layer of the network is like a different level in the building. With increasing levels of authority and expertise, each level you go up. So suppose you ask, what kind of car is this? Your query would arrive to the building on level 1. That first level is like the input layer in a neural network. When a question arrives, the input neurons start unloading boxes from the back of the truck in single file. In this case, each neuron grabs one pixel from the image that we uploaded, each analyzing just one small aspect of the entire shipment. Essentially, these neurons collectively represent the input data, which could be an image, a sound wave, or some other form of data. Once they each determine the value of their individual box or pixel, they use channels to notify their managers of what they've found. But at the company, each node's analysis is not valued the same. Communication from neurons with more expertise on the project, or maybe who have been at the company longer, are prioritized in the decision-making process over someone with less experience in that area. In a neural network, these are called weights, and weights are assigned to each connection between neurons to determine their level of influence on the output of the next neuron. The next floor up in the office building represents the first hidden layer, where the neurons are like managers with more experience than the input staff. The managers on this level compile several adjacent pixels from the input staff below using the priorities assigned to each report, the weights and biases. The effort at this level is to understand the small features, like any edges or corners in the image, to determine if their boss on the next floor should be notified. If the input data matches what the managers on this level are looking for, they will activate and follow another weighted process to communicate that activation to the next level. This next layer represents the second hidden layer and the next rung of authority in our office building that specialize in looking at broader features such as shapes or objects. They will then analyze that input with their broader expertise and based on the weights of the input below them to hone their predictions, following much of the same process as the nodes in layers below. This process continues through as many floors or as many hidden layers as is required by the question's complexity. As the signals get to higher levels, the patterns and relationships in the data become more clear, allowing the network to understand increasingly complex representations of what the input data is. That input data will eventually end all the way up to the top level of the building in the boardroom, or in a neural network, the output layer. Like a company's board of executives, the output layer contains the neurons that produce the final predictions of that neural network. The number of neurons in the output layer corresponds to the number of classes or outputs that the network is trying to predict. In this case, the board members may specialize in each type of car company, and by them all analyzing the inputs from the levels below them, they can determine which expert that final output belongs to. When an output is determined, that board member will then announce the final answer. And as mentioned previously, after this process is complete, there's a feedback through the company that just lets each employee know how efficiently they predicted what the final product was going to be, in a process called backpropagation. If their prediction was far off, then the value of that prediction will be decreased. But if their prediction was spot on, then the value of their opinion may be weighted heavier in future questions, allowing it to produce more accurate predictions or classifications in the future. So, as you can see, a neural network is a lot like a hierarchical organization, with different levels of authority and expertise all working together to process data and extract meaningful patterns in the most efficient way possible. This process can utilize various numbers of buildings with various floors and varying amounts of employees. Whatever is needed depending on the complexity of the problem being solved. Phew. Let me know in the comments down below if you're still with me or not. The applications of deep learning are varied and immense, including image and speech recognition, natural language processing, and autonomous driving, among others. As more data becomes available and computing power continues to increase, the potential for deep learning to transform industries and solve complex problems is vast. If you've made it this far and want to see more videos like this one, please subscribe to this channel and ring the bell to get notified when I post them. And consider sharing this video with somebody who you think may want to learn about AI too. Well, thanks for watching. All right, bye now.